Hello everyone. Today in this video we are going to see how does a recursion take place when it comes to draw a fractal tree in Java. Now before there are some requirements for this particular video, and that is a basic knowledge about swing, the paint component and the paint method, and then in the JFrame class, graphics, and a bit of mathematical knowledge. That's it. This video is actually intended for the beginners to show them how recursion works in real life and how a tree can be made out of nowhere just by using some kind of graphics and mathematics in just a few lines of code. Now before we look into the code, let's just see how it looks like. So this is a fractal tree, what we are looking like, what it looks like actually, and it also called as a Pythagorean tree. Now as you can see, there is a branch, and then another branch is at a given angle, and there is another branch is giving angle, and it goes on and on and on and on, right? Forever. And the angles keep on decreasing in a specific given order. So this is what we are gonna code today in this video. So let's just begin with it. And before beginning, I just want to create a application class here where we would be performing everything. And this is the main class where we'll be invoking the functions and all. As you know, remember, I just need to go to view, appearance, presentation. Yeah. So yeah. We'll be invoking the application.run method to be sort of formal. Let's switch back to application.java. Now since we're gonna make a graphics related thing, a 2D related thing, so we're gonna extend the JFrame because we need a window for that, and that will be present in the JavaX swing package. Then let's say just gonna have that public run method where we would have the instance of our application, and out there we would define the size for our application. Since I have a window dimension to be 1366 into 768, so I'd be saying it to be 700. Then set it visible so that we can see what's true. It's true. Yeah. Setting the app title is not mandatory, but I'll set that as a customary practice. Let's say project Java fractals. We are good to go with this run method. Now let's just have a constructor stating let's say the close operations, set default close operation JFrame dot exit and close. Yeah, good enough. Then let's say that the person who is using our application will not be able to resize the window. Now before just getting into the recursion part, we will have a paint method having a parameter of graphics, and in here I'll invoke that particular draw Pythagorean or a fractal tree. Okay, and now before we do anything, let's just switch over to our whiteboard. The structure of the fractal tree looks like this. There is a straight line like this, and then there are two branches. And again, as we have seen in this picture, there is another two branches like this, and it goes on continuously until we specify a specific height. Now this height will be a parameter in our recursive function that we will be naming it after in the coding session. Another thing that we need to keep in mind is about some mathematical functions like cos and sine. Now this cos will give us the x value and the sine function will give us the y value. Now as you know, Java has specific math functions for it, like math.cos and math.sine, which have double type parameters to accept some radian values. So there would be an angle which would be converted into radians, and then it would be passed to this particular cos and sine functions, so that we get the x and y value. If you ask why specifically cos and sine, now let me just show you with an illustration. Let's just say I have a graph, 2D graph like this. This is a y-axis, this is an x-axis. Okay, let me just label it y dash, x and x dash. Let's say we have a point P somewhere here. I hope that point is visible. Now this particular point P will have coordinates, or what we call as x1 and y1 values. Now this x1 and y1 values will be given in the start of the recursive function. And now let's say I have another point P2. It will also have the same x2 and y2 values. And now we'll have a function named drawLine, which would join these points, or specifically meant for drawing a straight line. So how we'll do that? It's provided by a graphics class that is present in AWT package. So we need not care about that. It's seen in the coding part. Now let's just, if we just want to join the line, we specify x1, y1 and x2, y2. That's it in the parameter of the draw line. Now let's say I have passed this x1, y1. I want the compiler to generate the x2, y2 values based on a given angle. How would we do that? We are given an angle that is in slope somewhat like this. Now we need to find this particular perpendicular or the y value. This can be found by sine, right? If you ask how sine would work, let's say this is theta and this is a triangle, right angle triangle. Now sine theta would give you, this is a hypotenuse because it's opposite to the 90 degree, so it's perpendicular by hypotenuse, or some people have it's perpendicular by hypotenuse, and then you will get this perpendicular. As you know, slope is given, slope is the angle basically, it's given by the angle itself. So you get the perpendicular by this sine theta, and the same goes for this cos theta also. With this cos theta you get the base, since hypotenuse is already defined by the given angle. And then you generate an x2, y2 value. Not like this, it's x2 and y2 value, which is the seed for this particular point. And now when you have this, you are good to go with a straight drawLine function, which will specifically draw a line for you. That is it for this particular mathematical thing. Now that we need to see is how the recursion would work. So basically it's something like we invoke a function right here. This function, if you don't know what recursion is, it's like this. This function again invokes itself here. Let's say xyz, and this is an xyz function, right? And until and unless there is a base case, this function can be called multiple thousand and up to an infinite times, hence exceeding the limit and giving you a stack overflow error or out of memory error. Okay. In order to avoid that, in recursion we generally follow a base case. The base case here would be the height of the tree. Now let's say that I have the height of the tree as 10. Each time I will pass some values to this particular xyz of the recursive function, we will decrease the height by 1. So it becomes 10, 9 minus 1, then 8 minus 1 until it goes to 1 minus 1, that is 0. The 0 will be the base case for this particular program. And we'll say if the height is 0, oops, my handwriting. So if the height is 0, we just return and we would not do anything. And until and unless it's not 0, we'll be performing all that functions of drawing a tree or branches from one branch. It will go on. And that's how we'll be doing a fractal tree in coding. So let's begin with the coding. Now since we have seen how it works out in the theoretical, let's just program it out. As we decided, there should be an x1 and y1 position. So let's say the x1 should begin at 250, x2 should be 650. Okay, then let's just have this particular function, public void draw fractal tree, having an x1, having y1, and as we discussed, we need an angle between the fractal trees. As I said this is an angle, we need that. Then which needs to be converted into radians. We need to have a graphics parameter, because in the parameter we need to have the graphics particular thing, because we need to draw a line inside this method itself. And then let's say we have a height for it. That's enough that we have. As we discussed out, this is going to be a recursive function, so we're gonna have a base case. The base case should be if height is equals 0, then we're gonna return. Else, if it is not the condition, if height is not 0 or it's 1, it's 2, it's 10, 9, anything, then we're just gonna define some kind of variables stating x1 plus int of math.cos, and as I said the cos will give you the x position of the point of the second point, and the sine function will give you the y position of a specific point. So here I'm gonna specify math.to radians and given an angle, and since this particular cos value is going to be in some decimal points, so I'm just gonna multiply it with the height and then multiply it with 10 so that it's quite visible. Same applies for y2 position also, where we'll just add the y1, and the only thing that change is this cos and sine. We discussed that, right? If you don't remember what I told you right now, just rewind the video, see the whiteboard part, and then again hop in here. Now that we have that, let's just draw the line. We are good to go with the line. We have x1, y1 as first point and x2, y2 as a second point. Good enough. Now that we have done this, let's just execute our program, but our program won't run just because this particular line, it stinks. Okay, just will specify an angle that should be minus 90 right now, just for example purpose, and the height of the tree should be 10. Let's just run this program and check it how it works. So if you see, seems something like, okay, we have a line out there, but wait, it's supposed to have a fractal tree like this. Where it is? Okay, so as I said we need to have the branches, and that branches will only be possible if there is recursion that is occurring. And for that, we specify this particular this draw fractal tree, given an x position, y2, an angle that should be, let's say, minus 20, a graph, and the height should be minus 1, because each time we move here, we need to decrease, or otherwise it would go on and on and on, and it will give you a Stack Overflow error as we discussed earlier. The same, let's say this particular thing will draw to angle minus 20 in this way, and we need to have the same for this way also. So it just copy this and will increase the angle by 20 here, and that's it. Now why do we need to pass this x2 and y2? Let's say I have this x1 y1 here and x2 y2 here. I draw a line, and then I don't want to draw a fractal tree from this point x1 y1. I want it from here in this point, and again here x2 y2. So it goes on and on and on in the same old classical function, and therefore we are passing x2 and y2 as a parameter in x1 and y1. Now let's just execute our program and let's see how it works. Alright, final. Drums rolling. And there you get a fractal tree. Oh, it looks beautiful. Wouldn't it be better if we had a black background and a white tree with some cherry blossoms on it? Let me just center it out and then figure it out. Let's say 350 and let's set the color to color.white. Oops, yeah. And here I set the background. Set background to color.black. Good enough. And as I said I need to have some kind of cherry blossoms. So if I need to have the cherry blossoms, there is only one condition. Like if height is 0, like for all these things the height is 0. So here we need to have a cherry blossom at the very end or the very tip. So let's set the color to be color.red and g.fill oval, and let's say x1 minus 2 y1, and let's say the height to be 5 and 5. That's it. Let's rerun the program. Fill oval will actually completely fill that oval. It will give you a circular disc like structure, if you see. And there you go. Beautiful it is, right? Of course. And that's how you create a fractal tree in Java. That's it for today's video. If you have liked the content, then do like, subscribe and share this video with your friends and other Java programmers out there. I know this is not the first video on YouTube on how to build a fractal tree. There are much more, but I think the explanation part may help you out a bit. Tell me how you like this video in the comment section below, and also if you have a suggestion for the next video, you can comment it down below. And of course you can connect with me on LinkedIn, Instagram, Twitter and Discord. For more details, I have my mail ID given below, so you can mail me out there. So that's all for this video. Thank you for watching this video. Goodbye.